Hello everyone, my name is Jason, and in this video I'm going to show you how to convert your X scores into Z scores. And you can see here I have two formulas that we're going to need to do this. The first formula is to calculate our population mean, which is mu, and that is equal to the sum of X over N. The other formula we're going to need is our z-score formula, which is equal to x minus mu over the standard deviation. Now, if you want to figure out how to calculate the standard deviation for a set of x scores, go ahead and look at my other video. But in this video, we're given the standard deviation to be equal to 2. Okay, so we're given the standard deviation. So we're going to start over here, and our end goal is to fill in this z-score column, because basically we're trying to convert each x score into its own z-score. But we start here, and the first thing I want to do is find out how many values do we have in our population. You can count 1, 2, 3, 4, 5. We have 5 values in our population, so I'm just going to put a 5 there. Sum of x. So here we're going to sum these x values. So we have 1 plus 5 plus 7 plus 3 plus 4. That's going to give us 20. And here we have our population mean. That's just the sum of x divided by n. So that's just 20 divided by 5, which then equals 4. Now we have enough information to start filling in this column right here, x minus mu. All we're going to do is take 1 and subtract 4. So 1 minus 4 is negative 3. Here we're going to do 5 minus 4 is positive 1. 7 minus 4 is positive 3. 3 minus 4 is positive 1. And 4 minus 4 is 0. So we calculated mu, and we used mu to then determine this column right here using these x values. Okay, now we need to find out our z-score for each of these x values, and if we look over at the formula here, we see it's x minus mu divided by the standard deviation. Well, we have x minus mu as our numerator already calculated for us, and we have our denominator over here, sigma equals 2. So easy, we're just going to put negative 3, bring that negative 3 over here, divided by 2, equals negative 1.5. So that's our z-score. Negative 1.5 is the z-score for x equals 1. When x equals 1, z equals negative 1.5. Let's continue. Here we have plus 1 divided by 2 equals plus 0.5. Here we have plus 3 divided by 2 equals plus 1.5. Negative 1 divided by 2 equals negative 0.5. And then 0 divided by 2 equals 0. So what you'll notice here, it's interesting, is that the z-score for x equals 4 is 0. And what you'll notice is that the z-score for x equals 4 is 0 is because our mean for the set of x scores is 4. Now if you remember reading about the theory before you do these calculations, and that's what I suggest you do, you'll know that the mean of a z distribution is always equal to 0. So basically the difference between the x-score distribution and the z-score distribution is that the x-score distribution has its own mean, which is in this case 4, whereas the z-score distribution, because it's standardized, it will convert that 4 into a 0. And so all these numbers are basically just telling you how far away each of these x values is from 4. Okay, now if that doesn't make sense right now, you can check out one of my other videos where I actually go more into detail explaining the difference between the x distribution and the z distribution. But that's it for now. If you have any questions, please let me know and check out my other videos in this video series. Cheers!